I know a lot of you listening probably use ChatGPT or Claude. You type a question, you get an answer. Today, we're going behind that curtain. We're going to learn how to automate that magic inside your own applications. And we're going to structure this like a proper workshop. This isn't just a random chat. We have a syllabus. We do. A very clear mission. By the time we're done here, you, the listener, should be able to do 4 specific things. Okay, what are they? First, you'll be able to initialize models from completely different providers, OpenAI, Anthropic, Google, whatever, using one single unified line of code. A massive time saver. Second, you'll know the difference between 3 critical methods: invoke, stream, and batch, and when to use which one. Crucial. Third, and this is the really fun part where you get into tool calling. This is how you let the AI fetch real world data, like checking the weather, giving the brain some hands. Exactly. And finally, we'll tackle what is, for me, the biggest headache in AI development: forcing the model to output structured data. Clean JSON, not just rambling text. All right, phase 1, the foundation. I want to activate some prior knowledge here. Let's say I build an amazing app with GPT-4. It's working great. Then a week later, Anthropic drops a new Claude model that's faster and cheaper. In the old days, I mean, like last year, what did that switch look like? Oh, it was painful. A total nightmare. You had to rewrite your API calls completely. OpenAI expects messages, another provider might expect prompt. The error handling is different. You were essentially vendor locked. And that's the problem this whole unified interface thing solves. It is. LangChain has this function in a chat model. Think of it as a universal adapter. It's a layer of abstraction. We're hiding all those messy details. So walk us through it. What does that look like in the code? It is shockingly simple. You import the function, and then you just pass it a string. If you want OpenAI, you pass, say, GPT-4. Just the string, just the string. If you want Anthropic's latest, you pass Claude-35 Sonnet 2024-0620. That's a very specific string. It is, but that's the point. You change that one string, make sure your API keys are set, and the rest of your app code stays exactly the same. The model object you get back works identically. And that supports pretty much everyone, right? OpenAI, Anthropic, Google, yep, Google Gemini, Azure, AWS Bedrock, Hugging Face, all the big players. Yeah, but here's the key part. It's not just about the name. You can also configure the model's personality right there. You mean like temperature? Exactly. You can pass in temperature or max tokens for length, timeout, all in that same initialization call. Okay, let's pause there for a second. A quick check-in for everyone listening. We just mentioned temperature. If you're building, say, a creative writing assistant, you want it to be a bit unpredictable, a bit inventive, yeah, would you set the temperature high or low? Good question. Think about it for a sec. If you guessed high, you got it. Higher temperature, closer to 1, means more randomness, more creativity. Lower, closer to 0, is more deterministic, more focused. So we have our model initialized. This brain is ready to go. Now we actually need to talk to it. Which brings us to phase 2. Invocation methods, right? Invocation is just a fancy word for calling the model. And there are 3 main ways. We'll start with the simplest one. Invoke. This is the standard call, right? Like sending an email and waiting for a reply, pretty much. You call model.invoke. Now, a key detail here is what you pass in. You can just send a simple string, like, why do parrots have colorful feathers? But in a real app, you wouldn't do that. Probably not. In a real app, you'd usually pass a list of messages, because context is everything. You'd have a system message that sets the rules, like, you are a helpful ornithologist, then a human message for the actual question. And you'd include the past conversation turns, too. Exactly. Invoke takes that whole history, processes it, and then returns the one final complete response. Okay, so invoke is the standard one-and-done call. But we've all used ChatGPT. I don't stare at a blank screen for 10 seconds and then suddenly get 3 paragraphs. I see the words typing out. Yes, and that is the second method. Stream, the typewriter effect. That's it. Technically, model.stream doesn't return one big message. It returns or yields little tiny chunks, message chunk objects. So as a developer, I have to loop through those chunks as they arrive. You do. You loop through them and add them together or print them to the screen. Why does this matter? I mean, why bother with the extra code to handle streaming? It's purely about user experience, UX. It's all about perceived latency. If a user sees a blinking cursor for 10 seconds, they think your app is broken. They're gone. But if they see text appearing right away, even if the total time is the same, the perceived wait time is 0. It keeps them engaged. It's a huge deal. Makes total sense. Okay, so that brings us to the third method, batch. This is where I hear there's a common misconception. Oh yeah, a big one. But let's define it first. Imagine you have 10 totally different questions. Why do parrots talk? How do planes fly? Hold on. You could just loop through them and call invoke 10 times. Right. But that's slow, because it's a sequential. You wait for the first one to finish before starting the second. Right. Model.batch lets you do them all in parallel. Exactly. It takes a list of inputs and fires them off at the same time. Okay, so here's the misconception. Is this the same as that batch API on the OpenAI pricing page? No. And thank you for asking that. That is the trap. The OpenAI batch API is for, uploading a massive file and getting results 24 hours later for half the price. That's server side. LangChain's model.batch is usually client-side parallelization. It's just using threads on your own computer to send a bunch of requests to the normal real-time API. So it's about getting speed right now and not about saving money overnight. Precisely. But there's a risk. What happens if you try to batch 1,000 requests at once? The API rate limiter is going to shut you down hard. It absolutely will. You'll get a 429 error. That's why model.batch lets you set max concurrency. You can say, process these 100 items, but only do 5 at a time. It manages the queue for you. That's fantastic. Okay, so invoke for one-offs, string for UX, batch for parallel work. That covers communication. Now, the exciting part. Phase 3, giving the model hands. Tool calling, right? Until now, our model is basically a brain in a jar. It knows a lot, but it's isolated. It can't check the current weather or query your database. It's locked in a room with only the books it was trained on. Tool calling, which used to be called function calling, is how we let it out. We pair a description of a function with the actual function. I really like the chef and sous-chef analogy for this. Can we walk through that? It makes it so much more concrete. Let's do it. It's the perfect way to see the flow. Okay, so the model is the head chef. Super skilled, super creative, but stuck in the kitchen. Cannot leave the station. Right, and you, the developer, your code. You're the sous-chef, or the runner. So a customer, the user, asks, what's the fresh catch of the day? The chef doesn't know, can't see the ocean. So what does the chef do? This is the critical moment. The chef writes a ticket. A request. A ticket that says, check inventory, fish. And they hand that ticket to you, the sous-chef. And this is the part people get wrong all the time. The model, the chef, does not run the tool. The chef doesn't run down to the docks. I cannot stress this enough. The model generates text. In this case, structured text that looks like a function call. It pauses and hands that request back to your code. So my code sees that request, I run off, I check the fish supply, and then what? You come back to the kitchen and you say, chef, we have salmon. You pass the result back into the model. And then the chef takes that new information and tells the customer, the fresh catch of the day is salmon. That's the loop. So in code, step 1 is define. Okay, you use the @tool decorator in Python. You make a function like getWeather, location.str. And here's a tip. You have to add a clear description in the doc string. Something like returns the current weather for a given city. Why does the description matter so much? Because the model reads that description to figure out when to use the tool. If you don't describe it well, the model has no idea what it's for. Got it. Step 2. Bind model.bindTools. Get weather. You're basically telling the model, hey, you have this tool in your toolkit now. Step 3. Invoke. We ask, what's the weather in Boston? And the response is not text. It's a tool call object. It'll have the name, get weather, and the arguments. Location, Boston. And then the final step is my code running that loop, getting 72 degrees, and feeding it back for the final answer. That's the whole dance. And models are getting crazy good at this. They can do parallel tool calls now. So you could ask for the weather in Boston and Tokyo at the same time. Yes, and the model will output 2 tool calls in a single response. Your code can run them both and feed both results back. It's incredibly powerful. It really grounds the AI in reality. But speaking of reality, sometimes we don't want a conversation. We just want the data. Which brings us to phase 4, structuring the chaos. Yes, this is a pain point for every single developer. You ask the model, extract the author and date from this article. And it comes back with, yeah, sure, I'd be happy to help. The author is Jane Doe and the date is... Right, and now you have to write some brittle reject script to find the name and pray the model never changes its intro phrase. If it says certainly next week, your code breaks. It's the worst. So with structured output is the solution. This method basically forces the model to skip the pleasantries and just return a specific rigid data structure. Let's do a worked example. We want to extract movie details, title, year, director, rating. How do we set that up? The gold standard approach is to use a library called Pydantic.
Which is Python's go-to for data validation.
Correct. You define a Pydantic class. Let's call it movie. You define the fields. Title is a string. Year is an integer. Then you just call model dot with structured output movie.
And when I invoke it with, say, tell me about the movie Inception, what do I get back?
You don't get a string. You get an actual instance of your movie class.
Yeah.
Movie title, Inception, year 2010.
It's already validated.
The system basically forces the model to output something that fits your schema.
Why does this matter so much? What's the big picture here?
Interoperability. AI is fuzzy. Databases are strict. Structured output is the bridge between them. If you want an agent that can read an email and then update a row in your CRM, you can't have fuzzy. You need exact fields. This guarantees it.
There's a little detail in the docs about include-true. When would I use that?
That's for debugging mostly. Sometimes you want the clean data object, but you also want to see how many tokens you use or if the provider sent back a safety warning. Setting include-true gives you both the parsed object and all that original metadata.
Nice. Okay, we've covered the foundation, the tools, and the data structure. I think it's time for the masterclass. Phase 5.
Let's do it.
These are the advanced topics that really separate the pros. We'll go a bit faster, but I want to get the why for each one. First up, model profiles. What are they?
Dynamic capabilities. You can check model.profile in your code to see, for instance, how big the model's context window is.
And the real-world application is context engineering.
That's it. Your code can check the profile. If the context window is small, maybe you decide to summarize a document piece by piece. If it's huge, you send the whole thing at once. You adapt your strategy on the fly. Smart. Next up,
multimodal inputs.
Seeing and hearing. You're not limited to text anymore. You can pass base64 encoded images, audio. You could just say, describe this picture, and pass the image data right in the message.
Reasoning models. I'm seeing more of these.
Yeah, these are models that show their work. They generate hidden thinking steps before giving you the final answer. For some models, LangChain lets you access those steps, which is great for understanding how it reached a conclusion. It's all about trust.
Prompt caching. This sounds like a money saver.
A huge money saver. If you have a massive system prompt that you send with every single query, you're paying for those tokens every single time. Caching lets you process it once, and then future calls just reference the cache. Faster and cheaper.
And finally, let's talk rate limiting, because nothing kills an app faster than success.
So true. Your app goes viral, everyone hits invoke at once, and the provider shuts you down. LangChain has a built-in in-memory rate limiter. You can tell it 5 requests per second, and it will automatically slow down your calls to keep you under the limit.
That is a lifesaver. It turns a fatal error into just a slight delay.
It's what makes an application robust.
So, looking back, we've covered a ton of ground in a pretty short time.
We really have. Let's just recap the journey. We started with a universal model interface. We learned to stream its thoughts for better UX. We gave it tools to check the weather, turning it from a brain in a jar into an agent in the world.
And we forced it to stop rambling and give us clean, database-ready JSON.
It's a powerful toolkit.
Absolutely. So for the listener who wants to get their hands dirty, what's the homework assignment?
Here's the challenge. Build a simple concierge agent. Initialize a model within a chat model. Give it one simple tool, maybe a function that calculates the length of a word. Ask a question that requires that tool, and then use it with structured output to format the final answer.
Simple inputs, tool use, and structured output. It touches on every piece of what we talked about.
Exactly. If you can build that, you've grasped the fundamentals of modern AI engineering.
I have one last provocative thought to leave everyone with. We talked about that tool loop where the model asks us to run the code, but I saw something in the advanced docs about server-side tool use.
Yes. The frontier. Some providers are starting to run the tools on their end. You just say search the web, and then their server runs the search and hands the result back into the model's context.
So, if that becomes the standard,
yeah,
are we moving toward a future where we don't even write the orchestration code anymore? We just define the tools, and the model does the entire loop itself in the cloud?
That is a big question. We might be shifting from AI engineers who build all the plumbing to AI architects who just design the tools and the goals. A fascinating shift to watch.
Something to mull over. Listeners, thank you for diving deep with us today. Go check the documentation. It's your best friend, and happy coding.
See you next time.